Today we're going to be looking at the distributive property and the associative property. First, the distributive property, using the distributive law of multiplication. The distributive property is sometimes called the distributive law of multiplication and division, but it's really pretty simple. It's about multiplying 46 and 5 in a different way. We normally just set this up as a regular multiplication problem, but with the distributive property, we want to break apart the 46. We want to break it into 40 plus 6, and then we want to multiply each of those pieces by 5. So we're going to multiply 40 times 5, and then we're going to multiply 6 times 5. Now 4 times 5 is 20, so 40 times 5 is 200. And 6 times 5 is 30. 200 plus 30 is 230. So the distributive property is a little bit like area multiplication that you learned in 4th grade, and it's about breaking up the parts of the number and multiplying them both by the other number. Now when we write distributive property, we also need to write it in a particular way. So for this problem, we're going to write 40 times 5 because we just did 40 times 5 right there. And we're going to put parentheses around it. We're also going to write 6 times 5 because we just did 6 times 5 right there. And when we were done, right here, we added the 200 plus 30. So when we write it in the parentheses, 40 times 5 and 6 times 5, we need to put an addition symbol in between, because that means once we multiply 40 times 5 to get 200, and we multiply 6 times 5 to get 30, we add them together to get 230. And this is what that's going to look like when we're doing algebra. Go ahead and pause right now and do 1 through 5 on your practice sheet, and then we'll pick up with the associative property in just a moment. The associative property of addition is a math rule that says that the way in which factors are grouped in a multiplication problem or an addition problem does not change their product. So let's take a look at this. We have 7 plus 6, and they have a parenthesis around them, and down here we have 7 plus 6, but the parentheses have been moved. All right, so 7 plus 6 plus 3 is the same in both. But in the first one, the parentheses are around 7 plus 6, and in the bottom, they're around 6 plus 3. Now, according to order of operations, we're supposed to add 7 plus 6 first, and we know that that's 13. And then we add the 3, and 13 plus 3 is, of course, 16. And so my answer here is 16. In the bottom, we know that we are supposed to add 6 plus 3 first to get 9. Then we add our 7 plus 9, and we still get 16. So either way we do this, we end up with the right answer. The purpose of the associative property is to let you know that it does not change the answer when the parentheses are moved within the problem. That means that it wouldn't matter which way it was done, we would still get the right answer. And we all know with algebra that a lot of times it does matter if the parentheses are moved, and that's very important. But this is a particular rule that is saying that when in this problem that it does not change the outcome. Let's take a look at the way you're going to see this today. Here we have 72 plus a box plus 13. Equals 72 plus 25 plus 13. Now you've got to solve for that box, but that's pretty easy because of associative property. We have 72 here and 72 here. We have 13 here and 13 here. But where this box is, we don't have anything. However, over here, we do. So I know that this is going to be 25. These are really quite simple problems today. But it's about understanding that they're switching the parentheses here so that it does technically mean that it's the associative property. But with associative property, you are going to have the same numbers. So we have 72, 72. We have a box, we have 25. We have 13, and we have 13. So the one that we are missing is 25. So 25 belongs in the box. And it does not matter that our parentheses are in different places. Go ahead and do the rest of your sheet, problems number 6 through 10, to show that you understand the associative property when it's applied to algebra.